Hello guys, welcome back to my channel. It is your maths teacher, Mr Moodliar, and I hope you are doing well. In this video, we're going to be looking at this problem where we are going to find the area of the shaded part. Okay, so if you're aiming to get a grade 5, 6, or 7 in your GCSE maths, this question would be very useful for you to gain some understanding. Now, I gave this question to my 11 set 1 over the week, and I can't believe it. When I was marking this question, only 22% of the students got this question correctly. And why is that? Well, let's look at it. Before we tackle this question, okay, we need to use Pythagoras theorem in this problem, and we are going to use area of a sector too, which is the following two formulae. Uh, Again, I've got this formulae from Third Space Learning. Thank you for sharing this formula. It's very useful. Anyway, let's crack on with this question. All right, so what do we have here? Okay, let's visualize the problem first. Okay, we have three circles. Okay, they've given you, okay, I would say the total length of the two circles. Okay, let's just look at it now. If I draw the diameter of one circle, then and then extend this. Okay, so we have two diameter, 2D. I'm gonna call it 2D now because one diameter and one diameter is gonna give me two diameters, which is equal to 10. Okay, and then one diameter would give me 5 centimeter. If the diameter is equal to 5 centimeter, we can say that the radius of that circle is 2.5. Okay, at the moment, I'm just gathering the information I can extract from this problem. It is a very difficult question. I'm not going to lie, but that's the point of having maths. Okay, that's the point of doing maths because every single time you solve a problem, you ask for more. And that's you becoming an amazing mathematician and a very good student who does not give up. All right, let's carry on with this question. All right, so far we've worked out the diameter is 5 and the radius is 2.5. Okay, now we're stuck now. Okay, so what I can do here, I'm gonna get rid of this, get rid of it. I'm gonna put the center of the circle. I'm gonna draw a triangle. Here's my lovely, beautiful triangle. Okay, now this triangle is a very special triangle. And why is that? Well, it is an equilateral triangle. Okay, so all the sides are the same. And how do I know that? Well, from here to there is the radius. From here to there is also the radius. From here to there is the radius. From here to there is the radius. From here to there is the radius. And that is also the radius. Okay, so it's an equilateral triangle. Okay, so we have from here, let me use different color pen now. That's one radius and that's one radius. Okay, so the base of the triangle would give me 5 centimeter because it's two radius. So we have 5 centimeter. So each length, okay, has a 5 centimeter. All right, so that's what we have so far. We have established that we have an equilateral triangle. What's my next step now? What's your next step? Let's find out then. Okay, so again, visualization is very important. I can see a sector. Okay, I can see a sector there. And where is the sector? Let's look at it. So this is the sector that I can see. Okay, let me just outline that with a blue pen. Okay, make sure don't go anywhere. I'm still here. Mr. Moodliar, your maths teacher. So we have a sector. We have a sector. Okay, so we have a sector, and the angle there would be 60 degrees. And why is that? Well, because it's a equilateral triangle. So all the angles are the same. Okay, very, very important. Now, how many sectors do we have there? Can we see? I can see three. Okay, so I'm just going to times that one by three because I see three sectors, three slices of pizza if you are really, really hungry. Anyway, let's crack on with the maths now. All right, so okay, so that's the shapes I can see so far. So what can I do now? Well, I can work out the area of the triangle first. Let me just rub this off. Okay, let's start over again. I want to visualize that. Earlier, we have established this equilateral triangle. So I can work out the area of the triangle. We need to make sure we have a plan. So area of the triangle, okay, which is, that's what we have, we call triangle. And we're taking away the area of the sector. So area of, how many sector do we have? Three. The area of the three, oh, let me just roll that off, of the three sectors. Okay, that's what we have. That's how you work out the area of the shaded region. Okay, so again, if this was your GCSE maths questions, I want to maximize marks. So using the formula earlier, we have the area of the sector, theta over 360 times it by pi squared. I'm going to be using that. Okay, so let's look at it now. So 60 over 360 times it by pi times it by the radius squared, which is 2.5 squared. That's the area of one sector so far. Let me just type that in my calculator. 360 times it by pi times it by 2.5 all squared. That would give you 3.27, 3.27 to three significant figures. How many sectors do we have? I'm going to multiply that one by 3. So 3.27, I would times it by 3, and that is going to give you, okay, so 9.82. So that would give you 9.82 centimeter squared. All right, now we work out the area of the three sectors now. We are going to work out the area of that beautiful triangle, which is equilateral. So again, we have a problem. Okay, so to work out the area of that triangle is base times it by the height divided by 2. So that's how you work out the area of the triangle. And we have a problem. Okay, the problem that we have right now, we haven't got the height. Okay, let me just draw this triangle, the height. Okay, and then the triangle that we have right now, okay, once we draw the height, is going to give you, a right angle triangle. So let's just look at it. So right angle triangle. Okay, remember this is also 5 centimeter. Okay, because I cut the triangle into half, so this would give me 2.5, and this is 5. And then from there, I'm gonna call this one h, which represent the height. So that's gonna give you the height. To work out the height, I am going to use uh, Pythagoras theorem, and it's a very, very useful theorem that we use in mathematics. Okay, so what do we have? Well, let's look at the longest side first. So let me extend my page. Okay, so it'll be h squared plus 2.5 squared is going to give you the longest side, which is 5 squared. Let's rearrange it first. So h squared is equal to 5 squared. take away 2.5 squared. H is going to give me square root of 5 squared, take away 2.5. Okay, let's type that in our calculator, which is going to give you uh, 5 squared, take away 2.5 squared. Uh, let's put that would give you 4.33. Okay, let's go up to my page. Okay, the area of that beautiful equilateral triangle is base times side divided by 2. We have just worked out the height, which is 4.33. Okay, so this would give me 5 times it by 4.33 divided by 2, uh, which is going to give you times it by 5 divided by 2. Okay, and that would give you 10.82. So my answer would be 10.82. So that's how that, which is centimeter squared. Okay, and that's how you work out the area of the triangle. So earlier we had a plan that to work out the area of that region is area of the triangle, take away the area of the sector. That's what we have. That's our initial plan. And do we have those area now? Yes, we do. Okay. So what do we have now? So 10.82. So I need 10.82 take away 9.82. Okay. So what would it be? So 10.82 take away 9.82, which is gonna give you exactly, well, not exactly, because earlier I rounded to two significant, I mean, two decimal places. That'll be 1 centimeter squared, and that's how you work out the area of that shaded region. Okay, shout to my students in the 11. They have finished the GCSE mock examination this week. They have worked really, really hard since the winter break. I hope it will pay off when you get your results in 2 weeks' time. And hopefully you watch my video. And goodbye for now. Thank you for watching. Bye bye.